Dear students, I am Ramesh, chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttangarai. Let us discuss Chatelier's principle. And according to Chatelier's principle, what is the statement? A system is at equilibrium is subjected to any disturbance or stress. Then the equilibrium shift in the direction to nullify the effect of disturbance or stress. So the equilibrium system, it is subjected to any disturbance. So it is subjected to any disturbance. Then what will happen? The equilibrium will shift forward or backward to nullify the effect of disturbance. So the equilibrium may shift. The equilibrium may shift any direction to nullify the effect of disturbance. The effect of disturbance is known as Chatelier's principle. Suppose we are taking what are the disturbance. Suppose the first one we are taking that the effect of concentration. Effect of concentration. Listen, suppose we are taking that hydrogen and is reacted with the iodine. These are on equilibrium, form that 2Hi. Then it is in equilibrium. It attains that equilibrium. Now concentration of the reactant and the products are equal. Then it is nothing but equilibrium. Now we are wantedly added Hi, some amount of Hi. Now it is a disturbance. What will happen? Now if the equilibrium subjected to any disturbance, then the equilibrium shift in the direction to nullify the effect of disturbance. So what will happen? The concentration of Hi is increases. So Hi concentration is increases in equilibrium, correct? So what will happen? It will be forward backward. So the equilibrium shift into backward so that to attain that again some other equilibrium is formed. And suppose if we are adding that hydrogen and iodine, we are adding that hydrogen and that iodine here, then what will happen? Here the concentration of the reactant increases. So concentration of the reactant increases, it will be forward reaction. So here according to Chatelier's principle, concentration of reactant increases. Reactant increases favors forward reaction. Forward reaction. And here concentration of product increases. Concentration of product increases. It will be favor backward reaction. That's all. So it is a backward reaction. So which reaction is forward? By increasing the reactant, forward reaction. By increasing the product, backward reaction. Or otherwise, listen, instead of increasing H2 and I2, if we are increasing the reactant, what is that? Forward reaction is forward. Now, instead of increasing hydrogen and iodine, we may remove certain amount of Hi. Then what will happen? Concentration of H2 and I2 increases and Hi is removed so that it is decreases. So by removal of product, it favors forward reaction. It favors forward reaction. So this is the concentration effect. Now, we may take the second one, the effect of pressure. So, here it is effect of pressure. we are take N2 plus 3H2. These are in equilibrium and form that 2NH3. So we are taking ammonia formation. And you know that pressure is inversely proportional to volume. Pressure is inversely proportional to volume. Now, effect of pressure is occur only if the equilibrium reactant and products are in gaseous state. So, all are gaseous. So, we may identify the effect of pressure. When pressure increases, volume decreases. Now, we may take here how many volume of reactant? Here 1 plus 3. So, that 4 volume of the reactant. 4 volume of a reactant. So, 4 volume. And here, what is that product? Product, this is 2 volume of a product. 2 volume of a product. So, it is a product and here it is a reactant. Then what will happen? Here, when pressure increases, what will happen? Pressure increases, volume decreases. So, volume decreases. How the volume decreases? 4 volume become 2 volume. So that it will be forward reaction. Forward reaction. Correct? In this forward reaction, 4 volume become 2 volume. So, volume decreases when pressure increases. Now, pressure decreases. What will happen? When pressure decreases, what is it? Here, volume increases. Volume increases, the product is 2 volume and the reactant is 4 volume. So, volume increases. What is the sign? It is backward reaction. So, when volume decreases in this reaction, then it will be forward, backward reaction. So, likewise, we may find out the effect of pressure. Now, we may take the second example. Here, H2 gas plus iodine gas. These two are in equilibrium and form the 2HI gas. Now, here all are gaseous. So, effect of pressure is possible. And how many volume? Here it is 2 volume. Correct? It is 2 volume. 1 volume and 1 volume. And here also it is 2 volume. Then what is the effect of a pressure? When pressure increases, volume decreases, but there is no volume is decreases. Both volumes are equal. So, there is no effect on pressure. So, there is no effect on pressure. So, this is pressure has no effect for this equation when delta Ng is 0. Delta Ng is nothing but number of moles of gaseous product minus number of moles of gaseous reactant. So here it is 2 minus 2 becomes 0. So delta Ng is 0. There is no effect on pressure. Now we may take the effect of temperature. For example, we are take N2 plus 3H2 gas and form that equilibrium. Then it is 2 moles of ammonia. Then you know that delta H. What is it? Delta H? Delta H is nothing but change in enthalpy. And it is always for a forward reaction. If they are mentioned that the delta H value, it is for only forward reaction. And here delta H value is minus 92 kilojoule. Actually, for 1 mole, it is minus 46 kilojoule per mole. And here there are 2 moles, so that it is 92 kilojoule. And here the negative sign indicates, so if it is a negative, then indicates exothermic reaction. And if it is a positive, then it is endothermic reaction. Endothermic reaction. Okay. Now, equilibrium reactions consist of 2 reactions. One is forward and backward. Now, delta H is always given for a forward reaction. Now, forward is a exothermic. So, this is a forward reaction. So, forward is a exothermic, then backward is a endothermic. Backward is endothermic reaction. Now, according to Chatelier'S principle, when temperature increases, favors endothermic reaction. So, here when temperature increases, favors endothermic reaction. Endothermic reaction. So, listen, it is easily identified. When temperature increases, favors endothermic reaction. So, what will happen? Here, when temperature increases in this reaction, temperature increases. When temperature increases, favors endothermic. Which one is endothermic? Backward reaction is endothermic. Correct? So, what is a backward reaction? Ammonia dissociated into N2 and H2. So, when temperature increases, dissociation of ammonia is favored. Dissociation of ammonia. So, dissociation of ammonia is favored when temperature increases. Then, when temperature decreases. When temperature decreases. When temperature decreases, favors the opposite, exothermic. So, what is the exothermic? Formation of ammonia is a exothermic. So, when temperature decreases in this reaction, forward reaction is favored. Forward reaction is nothing but formation of ammonia. Formation of ammonia. So, this is the temperature effect. So, to get the highest yield, the optimum temperature. Optimum temperature. So, optimum temperature is the temperature to get the maximum yield of your product. So, it is the temperature effect. Now, we may take the next one here, effect of addition of inert gases. Effect of addition of inert gases. Inert gases. And if you are adding a inert gas, what is that inert gas? They didn't reacted with any other. Why it is didn't reacted with any other? Because of stable electronic configuration, that is NS2, NP2. So here inert gas or NS2, NP6 electronic configuration except helium. So these are all stable electronic configuration. So it does not reacted with any other. So addition of inert gases at constant volume. If you are adding, the inert gases is added at constant volume. It has no effect. So, it has no effect. So, at constant volume we are added, there is no effect on equilibrium. And the fifth one, that is effect of catalyst. Effect of addition of catalyst on equilibrium. On equilibrium reaction. Now, what do you mean by catalyst? Catalysts are the substances which alter the rate of the reaction. For completion of the reaction, it remains unchanged in chemical composition and mass. And while we are adding a catalyst, suppose we are taking N2 plus 3H2 and equilibrium 2NH3. It is a Haber process and the catalyst is iron. While we are adding a iron catalyst, what will happen? And here there are two reactions, one is a forward and backward, and both reactions are faster. Then what will happen here? The attainment of equilibrium is faster. Attainment of equilibrium become fast while adding that ion. Okay, listen. If you are adding that ion, what will happen? So, when catalyst is added, the activation energy decreases and it will become the newer part. Suppose we are taken, it is the reactant and here it is the product. Now, it is nothing but activation energy. And it is a normal reaction, absence of catalyst. If you are adding a catalyst, what will happen here? That is, the activation energy decreases while adding a catalyst. So, while adding Fe, the activation energy decreases. So, what will happen here? More amount of reactant is cross the energy barrier and form the product. So, here, while adding a catalyst, the activation energy decreases. So, the rate of the reaction becomes faster. And here there are two reactions. One is a forward and backward. So, both the forward and the backward reaction is fastened so that the attainment of equilibrium becomes fast by adding a catalyst. So, these are the effect of concentration, pressure, temperature, catalyst and that is addition of inert gases. Now, we are take One-Hoff equation. One-Hoff equation is explain the temperature dependence of equilibrium constant. And here, according to One-Hoff equation, we may determine the temperature dependence of temperature with equilibrium constant, that is Kc. Now, we may take the thermodynamic equation, that is delta G naught, which is equal to minus RT ln K. So, delta G naught is nothing but Gibbs free energy and R is a gas constant and T is a temperature and K is nothing but equilibrium constant. And we know that is delta G naught is equal to delta H naught minus T into delta S naught. So, substitute the value. What is that? Minus RT ln K, which is equal to delta H naught minus T into delta S naught. And delta H naught is nothing but change in enthalpy. Delta S naught is nothing but change in entropy. Now, we may take that here positive, negative become positive. So, what is that? RT ln K, which is equal to minus delta H naught and plus T into delta S naught. Now, we may take ln K is equal to, what is that? Minus delta H naught by RT plus T into delta S naught by R into T. So, T cancel. So, what is that? Here, that is delta H naught by RT and plus delta S naught by R. It is nothing but ln K value. Now, we may take here, we are taking the differentiate this equation. So, this equation get differentiate with respect to T, that is temperature. Then, we are taking that differential equation. So, differential equation. Yeah, for differential equation, we are taking that is d ln K, which is equal to, that is d of minus delta H naught by RT. And it is become a constant, so it will become 0. Listen, here that is differentiation of x power n is nothing but n x power n minus 1. Now, dx power n equal to n into x power n minus 1. And here we are taking that, here that is minus t power minus 1. It is inverse, correct? That is a negative 1 by t is nothing but t inverse. Now, what is that? It is the differentiate. So, differentiate of this one, then it is negative sign and n into x. So n is nothing but minus 1 and into t is nothing but x and minus 1 power minus 1. So what will happen here? It is a plus and it is t power minus 2. So t power minus 2 is nothing but 1 by t2. So while differentiating this one, delta h by r t square. Negative differentiate of minus 1 by t is nothing but 1 by t square. So that it is rt square. So it is ln k. So ln k, which is equal to delta h by dt. So with respect to time, then it is equal to delta h naught by rt square. Now we may take that ln k. Ln k, which is nothing but delta h naught by r into, that is dt by t square. Now take the integration. At T1 temperature, the rate constant is K1 and at T2 temperature, the rate constant is K2. So integrate the equation, that is with respect to K1 and that K2, and it is ln K, which is equal to, what is that here, delta h naught by r constant, integrate with respect to T1 and T2, and here dt by t square. Now we know that the integration formula here, that is integration of x power n into dx is nothing but, that is x power n plus 1 by n plus 1. It is the formula. By taking this, what is that here, 1 by t square. 1 by t square is nothing but t power minus 2. And here, what is that? T power minus 2 plus 1 divided by minus 2 plus 1. So what will happen here? T power minus 1 divided by minus 1. So it is nothing but minus 1 by t. So we are getting, that is minus 1 by t. So here we are taking, that is delta h naught by r, and here it is minus 1 by t, and here t1 and that t2, and we are taking here, that is ln k, and here k1 and that k2. So what is the limit here? That is ln k2 minus k1. So here ln k2 minus ln k1, which is equal to delta h naught by r, and here we are taking here minus 1 by t2 minus into minus plus 1 by t1. Correct? Now solving this, we are taking, so here ln k2 by k1, which is equal to, what is that here, delta h naught by r into, what is that here, minus t1 and plus t2 divided by t1 into t2. Now what is that here, delta h naught by r into, we may arrange it here, t2 minus t1 divided by t1 t2, and it is nothing but ln k2 by k1. And you know that the ln value, what is it, the ln value? It is 2.303 log k2 by k1 is nothing but ln value. Then is equal to delta h naught by r into t2 minus t1 divided by t1 t2. Now what is that here, log k2 by k1, which is equal to 2.303. So delta h naught by 2.303 r into t2 minus t1 divided by t1 t2. Then it is the want of equation. From this we may determine the temperature dependence of K1 and that K2. Thank you.